In this video, I am going to explain how we can prepare the part program for pocket milling. The main aim of this session is to familiarize the students about pocket milling, the instructional objectives. This session is mainly designed to able to demonstrate a comprehensive understanding of the process by accurately identifying and describing each stage involved, including the tool selection, workpiece setup, and the sequence of machining operations performed. Learning outcomes. At the end of the session, you should be able to articulate the key principles and concepts underlying pocket milling, the ability to select appropriate cutting tools, set up the workpiece, adjust machine parameters, and execute pocket milling operations effectively. So, pocket milling is a machining operation used in milling machines and CNC machining centers to remove the material from a workpiece in the form of a pocket or cavity. Pocket milling is widely used in various industries for creating pockets, slots, and complex cavities in components. It offers a highly efficient and precise method for material removal, particularly in the production of parts with intricate geometries. So there are several types of pockets that can be machined using pocket milling operations, each serving different design and functional purposes. Here are some common types of pockets we are using. Now let us see that here it is a rectangular pocket. So on this workpiece, we need to milling this rectangle shape of the cavity we want to produce. So now we can here in this the assigned this corner is a horizon for the coordinate system. Here rectangular coordinate system are used. This axis is aligned to the x-axis and this axis is aligned to the y-axis, and the top one is the z-axis. So we can control the table movement with the help of these x and y parameters, and you control the tool with the help of the z parameters. This is the rectangular pocket. So what is the syntax for using the rectangular pocket milling? Now let us see that here this is the syntax we are using: G24 X Y L W Z R Q D F. Now let us see that what is the X, Y and X and Y coordinates of the lower left corner of the pocket. So whatever the coordinates we are referring the corner, with reference to that corner you can take the dimensions of the remaining parameters. So now here assigned xy is the coordinates of the lower left corner of the pocket. L is the pocket size on the x-axis in mm, and W is the width of the pocket on the y-axis in mm, and Z is the pocket depth in mm, and R is the safety distance, that is in terms of mm, and Q is the cutter side shift distance for the next chip, and D is the flange, the amount in the Z axis, and F is the feed or progress in terms of mm for minute. So this is the mainly we are using cycle that is for making the pocket milling. G24 X Y L W Z R Q D F. Now see the program. N10 G21 G94 and N15 G91 G28 Z0. So now here already earlier videos I explained what is the indication of N10 15, like these are the block numbers, and these also I explained. If you want you can see the earlier videos. Now the G28 Z0 is the send the tool to the home position, and here G28 X0 Y0 send the workpiece to the home position. Then you can select the particular tool M06 to T01. Then M03 that is the spindle starts rotating in clockwise with a speed 1500, and this is the pocket milling, rectangular pocket milling cycle. G24 X10 Y10 L75 W50 Z5 R2 Q3 D1 F65. And once this is one line is sufficient to make the entire pocket milling. That is the beauty of this part programming. Then you can send once completed the part programming, send first tool to the home position G28Z0, then send the workpiece to the home position, then the spindle stop, then program end and rewind. This is the simple program you can use to make the rectangular pocket milling. Next we will see the circular pocket milling. This is the circular pocket milling. We can make the circular the cavity on the surface. We are using this circular pocket milling. Now let us see the syntax for circular pocket milling. Almost the similar, only that circle center is and one of the point on the circle is different. Now we are using the G25. You can see that G25 X and Y, I, J, Z, U, R, Q, D, F. Now let us see that what is the X and Y coordinate of a point on the circle. On the circle, any point you can take, that coordinates you can mention X and Y, and I, J indicate the circle center coordinates, and Z is the pocket depth, how much depth you want, that you can mention here. R is the safety distance above the workpiece, what is the safety distance, that you can mention, and Q is the cutter's side shift distance for the next chip, and D is the plunge the amount in the z-axis, each time how much it will go inside, that will tells the D value, and F is the feed, the progress in mm per minute. Now see the program. G21, G94, G28, Z0, the tool sent to the home position, then G28, X0, Y0 workpiece sent to the home position, then spindle starts tool change, T01, M06, T01 tool change, M0 the spindle starts rotating in clockwise direction with a speed as 1500, and cycle is G25, here not 24, 25, X80, Y20, I80, Z70, Z5, R2, Q3, D1, F65. And the tool will send to the home position and workpiece is sent to the home position, spindle stop and program and rewind. This is the program used to make the circular the pocket. Now let us see the self-assessment questions. Which type of tool is typically used in pocket milling? So that is a boring, drill bit, milling cutter, lathe tool. The correct answer is a milling cutter. Second question. In pocket milling, what is the term pocket boundary referred to? So the tool's cutting path, material thickness, outer edge of the enclosed cavity, and workpiece dimensions. The answer is outer edge of the enclosed cavity. Now what are the different terminal questions? So these are the different terminal questions. You can go through it and prepare for a better understanding of this pocket milling programs. So these are the further reference books and websites are mentioned. I think with this, this video is completed. I hope everyone understand how we can prepare a part program for pocket milling. Thank you.